Hey guys, my name is Andre, and this is the video on simple machines. So if you didn't know, here on the Rigatoni Robotics YouTube channel, we have an ongoing series teaching some basic STEM skills. This is going to be a part of that series. So what is a simple machine? Well, to answer that, you first need to ask what a machine is. A machine is going to be any device that makes an action easier. So a simple machine is one of these 6 listed here that consists of only one moving part. Any complex machine is going to be a combination of these 6. So if you think of any complex machine, let's say a lawnmower, well, even a lawnmower is going to be a combination of these 6 simple machines. Now, how does a simple machine work, you ask? Well, that all combines into how you define work. Now we're going to have another video on the channel about some basic physics, and this video is going to pair very well with that. So it might help a lot if you go and watch that video first. But to just give an overview, we're going to talk about what work means in physics. So if you look at this equation here, this is what work means in physics. Work, the W, is equal to force times distance. Now a simple way to talk about a force is it's a push or a pull. Now, a force is measured in distance. Sorry, force is measured in newtons. The D here is distance. This is measured in meters. So here you have how many newtons have you applied times the distance that you've applied it over, and that is going to get you work in joules. So now let's move back here and look again. Each of these simple machines works on the concept that when you perform some action, no matter how you perform it, it's going to take the same amount of work. So when you use a simple machine, you're not changing how much work you're doing in the physics sense. You're instead changing what distance you apply that work over. So if we go back to, let's say, an inclined plane here, you were no longer just lifting this barrel straight up and putting it here. You're rolling it over a greater distance. But with the knowledge that we are doing essentially the same action, getting it to the same location, that means we're doing the same amount of work, which means if distance is increasing, work is the same. That means force is decreasing, which is what makes it easier to use that inclined plane versus just lifting it. This is the concept that all simple machines operate under. So let's just go through each machine and just give a basic overview of how that works. So now we're going to go into each of these simple machines a bit more in depth and talk about it specifically. So first off, we have the lever. A lever is any tool that pries something loose. Each lever consists of 2 parts. First is the arm, which would be this red bar here, and then the fulcrum. The fulcrum, it sounds like a complex word, but that's simply the point which the arm is touching up against, is like rotating around. So think of a seesaw. The fulcrum of the seesaw is the point in the middle in which the seesaw is balancing against, going back and forth. So the lever works on a bit more of a complex concept called torque. Torque might be covered a bit more in our other physics videos, but to get just a basic overview, a torque is simply a force which causes rotation. This is a torque right here, because when this arm pushes against this side, it's going to rotate over this fulcrum, and this side of the arm is going to go like that. A torque is measured by the force being applied times the distance from the fulcrum. So if you were to hypothetically apply this force from further away, so instead of being this distance from the fulcrum, it's instead further away, like over here, then the torque would be greater, and it would be easier to move this rock. That's how levers work, is by increasing the distance from the fulcrum to increase the torque. And that way you don't have to actually apply more force. You're applying the same amount of force yourself, but the simple machine is making it easier. Next, we have inclined planes. Inclined planes are probably the most common. Think about these, it's like the ramp coming out of the back of a moving truck. Instead of lifting the box straight up, you push it up the ramp, and this uses the concept of work, force, and distance that we were talking about earlier. You're increasing distance, work stays the same, therefore the force is decreased. Now, a wedge and a screw might not actually seem like this, but these are two types of inclined planes. If you look at a wedge here, a wedge is actually just an inclined plane that's been rotated and you're now using the pointed end. You use a wedge to usually split something. Shown here, it's splitting this log. And the most common type of wedge, or the one that's easiest to visualize at least, is an axe head. And then the screw, this one's hard to see, but a screw is actually a type of inclined plane. Excuse me. It's a inclined plane that's actually been wrapped around a cylinder. That's a bit hard to conceptualize, but that's how it's considered in terms of simple machines. A screw, you probably know, is used to hold two things together. Now, let's talk about wheel and axle. So a wheel and axle is the wheel, which is the circular disc, attached to a central rod, which is called the axle. Now, it depends on how we are using the wheel and axle. This is extremely common. Think about it in cars. I mean, anything with the wheel is usually using the wheel and axle. This one's pretty easy to think about in your head. If you put something on wheels, it's going to be easier to move it. Think of a wheelbarrow. Instead of picking something up, you're pushing along any sort of cart. It's always applying the same concept. Wheel and axle also uses the concept of torque to reduce force. This is a bit more complex, so we're not going to get into how torque is used here. Just know that by transitioning to rotational, using the rotational, you make the force smaller and it's easier to accomplish that work. Finally, the pulley, once again a form of rotational. Instead of having an axle, though, you now have a rope wrapped around the pulley. Basically, by pulling on one side of the rope, it spins the wheel and you have the action performed on the other side. This is a very simple pulley with only one wheel. This would not actually give you any sort of advantage. You would be applying the same amount of force here. But you can have very complex pulleys where you add more and more wheels. And depending on how the wheels are positioned and how the rope goes around the wheels, you can have pulleys that accomplish very specific amounts of force versus direction to get whatever you wish to accomplish. So that was just a basic overview of each of these simple machines. Know that in essence, a simple machine is just a way of reducing the force that it takes to do something. Reducing the force is what makes it easier for us to accomplish it. Each of these simple machines works in the basic concept of that work in the physics sense is going to remain the same for each action. Therefore, you need to change what distance you apply the work over to reduce the force. And also a very central concept to these simple machines is the idea of rotational. This is a more complex idea, so we might see more of it in other physics videos, but that's just an overview. So I hope you learned something from this video. You might see more concepts similar to this on the channel, so stick around and look for other videos that are being posted here. Thank you for watching.